In this video, I'm going to be showing you how to take notes while you're reading. This is very important, number one, when you're reading a lot of different articles for your thesis or seminar or your own paper. It's also going to be very important for studying for a test if you have tests based on articles. And even if you just have to write a summary of an article for a course, it's also a good way to write the summary, and I'll show you how to do all of that. I'm going to be using a very short article today, and if it's a longer article, as we've taught you elsewhere in this course, you should be reading first sentences of every paragraph to find the paragraphs with more information that you want to read more in depth. Since this is a very short paragraph, I'll be reading the whole thing. So I'm doing it a little bit differently than we teach in class usually. And the article that I'm going to be reading with you today is Saharan silver ants can control EM waves. You'll notice that I have it open on the left side of my screen, and on the right side of my screen, I have a blank Word document. I'll be taking notes on the Word document. The first thing I want to put on the Word document is the citation, so I can find the article again if I need to. Also, when I'm writing a thesis or seminar paper, I have to use all of those references at the end. So it's good to put the reference, the citation, right at the very beginning. So if I go back to the library where I found the article, I can just click Cite. And here I get the citation right there for me, as is, all taken care of. Okay, so you should always do this first. Now we're going to start reading. Saharan silver ants can control EM waves. Nanfeng Yu, assistant professor of applied physics at Columbia Engineering, and colleagues from the University of Zurich, University of Washington, have discovered two key strategies that enable Saharan silver ants to stay cool in one of the hottest terrestrial environments on Earth. So this is, I think, is important. So I'm going to highlight it. Same way that you would highlight it regularly if you're reading it on paper. What I'm going to do now, though, is I'm going to copy it. And I'm going to put the whole thing in my Word document. Okay. I like cleaning it up, but you really don't have to do this. And what this tells us is they have discovered how ants stay cool in very hot place. Okay. I've now taken notes on my reading. I no longer need this quote because I already have the notes on it. I'm not going to read the whole thing. I can read it more efficiently, more quickly by reading my own notes on it. Certainly if I'm taking notes in my first language, and I'm reading in the second language. Since I no longer need this, I'm going to put it in gray. Because I can still see it, I can still go read it, I can go back to it, I can refer back to the article with it, but I don't really need to, when I'm studying, I don't need to look at it anymore. Okay? Use team as the first to demonstrate that ants use a coat of uniquely shaped hairs to control the electromagnetic waves over an extremely broad range from the solar spectrum, and that different physical mechanisms are used in different spectral bands to realize the same biological function of reducing body temperature. Okay, so how do they do it? They do it with certain hairs. And again, I gray this out because I already written my notes on it. I don't need to read that again. Using electron microscopy and ion beam milling, Yu's group discovered that the ants are covered on the top and side of their bodies with a coating of uniquely shaped hairs with triangular cross sections that keep them cool in two ways. So I already have basic information over here. The hairs are also emissive. The hairs are highly reflective under the visible and near infrared light in the region of maximal solar radiation. So this is how they do it. Hairs are also highly emissive in the mid-infrared portion of the electromagnetic wave. They serve as an anti-reflection layer that enhances the ant's ability to offload excess heat via thermal radiation, which is emitted from the hot body of the ant to the cold sky. So even if you don't understand all of these words, what we do understand is that the ants can offload or get rid of excess heat. This is weird, but okay. Okay. This passive cooling effect works under the full sun whenever the insects are exposed to the clear sky. The researchers found that the enhanced reflectivity in the solar spectrum and enhanced thermal radiative efficiency have comparable contributions to reducing the body temperature of silver ants by 5 to 10 degrees compared to if the ants were without the hair cover. This is all one sentence. I'll copy the whole thing. I now have here all my notes, and everything else is grayed out. This is possibly the most important thing that you're going to do now. The next step is probably the most important. Now that you've read the article and understand the article, we're going to use what's called the Feynman method or the Feynman technique for learning. And Richard Feynman, a very famous physicist and a very wonderful teacher and explainer, said that if you want to make sure you understand something, be able to explain it. So how would I explain this to, let's say, a third grader? How can I simplify it such that even a third grader can understand it? So here I'm going to do a Feynman recap. So these are Saharan silver ants. So now I've written in such a way that even a third or fourth grader can understand it. Because the ants have certain hairs, very special hairs, that reflect the light, that help the ants stay cool. And you may say to me, but maybe they don't understand the word reflect. And I could say, okay, Okay, so when you use this method for taking notes, it's a very good way for having just what you need to remember when you go back to write your seminar paper and find many different articles and synthesize them and write a very good paper.